Thank you so much for being here. Thanks, Vasily, for the invitation to speak. I'm super excited about being able to engage with a community that's very different from the one I usually engage with. So I want to tell you about peer grading and data mining. And I've been doing peer grading for about 3 years, and I've been bringing ideas from theoretical computer science and economics to bear on this problem. I want to tell you sort of a little bit about my thinking there. And I'm hoping that uh, you all can help me, identify connections that there might be here with data mining, which I've done a lot less of and have a lot less experience with. Cool. So let me tell you, just to give you a little bit of background for my perspective and how I come to this problem, is I'm interested in the following, what I see as a grand challenge for computer science. And that is we've gotten digital computers to do really amazing things. Can we understand computation in the wild outside of digital computer systems and get those computations to work well? Um, and I have a lot of examples I like to think about as sort of environments where you can think about the implicit computation that's happening in those environments. And maybe by making that computation explicit, we can understand those environments and make those computations work more efficiently and achieve better outcomes. A key sort of computational primitive that binds these environments together is local, individual, or strategic optimization. There are individuals in these systems that are optimizing for themselves, and they optimize, as I said, for themselves. Of course, as the architect of such a system, or as an analyst, what you care about is good global outcomes. When everyone is strategizing for themselves, following their local or individual incentives, does the system as a whole achieve good outcomes? Uh, a key application area that I think this grand challenge is many decades off in realizing, and so it's helpful to have key application areas where we can start to get a taste for it without the big gap between where we are now and where we want to be. And that key application area I think is online markets, which I view very broadly. So it includes things like Uber, Stack Exchange, Google Scholar, and Tinder, where people come to these online platforms and they interact. Sometimes there's one side with drivers and riders like Uber. Sometimes everyone plays both sides. People write papers, and people go to Google Scholar to learn about papers. And so this is a sort of a rich area for thinking about how groups of individuals mediated by platforms get outcomes that are really transforming the world we live in right now. And an application in this space that I think is incredibly interesting, especially as an academic, is peer grading. And one of the reasons why I think this is incredibly interesting is because it satisfies a lot of the conditions of these other marketplaces. But every time I teach my class, I get to tune and tweak the peer grading algorithms to try to figure out what makes a peer grading algorithm work well. Whereas I have a lot harder time tuning and tweaking Uber's algorithms or tuning and tweaking how Google Scholar works. So as a research platform, peer grading is incredibly has an incredible amount of possibilities in terms of faculty at many universities trying different peer grading approaches and really understanding how to get these marketplace peer grading, sort of viewing it as a marketplace to work. So my research area, I come to this from the area of mechanism design, and mechanism design looks at how do we design the rules of these systems to get good outcomes when there's individual strategic behavior. Okay, and so basically what we're doing is combining the ideas of algorithm design with game theory. Okay, we're having algorithms which take the inputs from users, but we have to take game theory into account because the users in the system might be strategic about how they provide those inputs. So that's sort of my background. I'm a theorist. I tend to write papers with theorems and proofs in them. I haven't done so much of that in the peer grading space. I'm going to tell you about a system we built mostly in this talk. Cool. So taking this perspective of computation in the wild, I'm going to view the classroom as a computer in the wild, where students are local optimizers strategizing for themselves for whatever their objective is, good grades or learning. Graders and instructors are imprecise operators that try to sort of, get things to work well. There's a syllabus which tells you the rules. Students have incentives such as minimizing work or maximizing grades. And as a principal designing my uh, the the classroom experience, I want to minimize the work of everybody. I want to maximize the learning of the students, and I want a system that fairly assesses the students. That's sort of a first blush. So, you could say, what's the best syllabus to achieve these goals? Okay, and you can view this as an optimization problem of I want to figure out how to design my syllabus to achieve to as this ecosystem I'm talking about. And so here's a question that I think has motivated some of the work that I've been doing in this space. Which of these two solutions is going to give faster, more accurate answers to assessing students? Should I have one TA grade 100 submissions in my class? Or should I have my TA grade 10 submissions and have 100 of the students in the class each grade 3 submissions? And I mean, it's kind of obvious that this is going to be faster because parallel computation is faster than sequential computation. And also, it might even be more accurate because a TA grading 100 submissions is sort of a tiresome task. And after you've graded 90 of them, are you really doing that great a job on the last 10? So I think there's a lot of opportunity to really make these systems work a lot better. My primary concerns what I did a fairly extensive survey of literature before I got into the space. My primary concerns are the incentives of the peers to provide accurate, high quality reviews and the learning outcomes that you achieve by adding this task of peer review to the set of tasks you ask students to do. And in my study of the literature, incentivizing the peer reviewers to actually put in high quality reviews was really underexplored. And with my background in mechanism design, thinking about incentives, this was sort of the main thing that I sort of actually have qualifications to study. Great. So we built the peer grading system at Northwestern. It's a Canvas plugin. I've taught a number of different classes in this peer grading system from, freshman intro to CS concepts classes to junior, senior intro to algorithms to elective classes like online markets. And I've taught PhD level advanced mechanism design classes with the same platform. And it works very well for all of these levels of students. As I said, my research focus are incentives for in the review grading algorithm and analysis of the learning outcomes we get from using such a system. I've got a number of collaborators at Northwestern in this. A bunch of students have been making sure that everything actually happens. As I said, my background is in theory and algorithms and mechanism design. Doug Downey has been providing a lot of machine learning expertise to the project, and Nell O'Rourke has been helping us with the HCI and CS plus LS questions. Let me very quickly go over some of the advantages that peer grading offers in the classroom environment. And these observations come from my Intro to Algorithms class, where I actually did a survey of the students and got data. This was sort of early on in the study. So I think there are four main things that peer grading systems afford. One of the primary for me is the learning by reviewing. I think that students, when they are asked to assess other people's work, they can potentially have another avenue to interact with the concepts of your course, and this can be very beneficial with them in learning. Reducing the teacher grading, especially in MOOC-sized courses, this is critical. In our courses at Northwestern University, it's not quite as critical, but it really does allow the TAs to refocus their tasks on, spending more time with one-to-one interactions rather than spending, hours late at night doing grading. A third thing on my list is promptness of feedback. I think it's a game changer for students to get feedback in a couple days on their work versus a couple weeks. And um, getting feedback before you have to do the next assignment is critically different from getting feedback after a couple assignments later that you've already done. And the fourth thing that I think is exciting about this project is that it enables data mining questions. Cool. So I did a survey I tried to assess, these criteria, and we did a survey of students in the class and asked them whether they agreed or disagreed with whether the system helped them learn. This is sort of anecdotal. It's not a very rigorous survey. And so basically, students, a majority agreed that it helped them learn the material, and a majority agreed that it helped them write better. What I think is most interesting is if you separate the data out across whether the students are A students or whether the students are, lower end of the spectrum, the students on the lower end really found it much more helpful than the students on the high end. And I think that's something you could expect. I think the students on the high end would have done great learning the material without these additional tasks of peer grading, whereas the students on the low end actually really thought they benefited a lot from it. Reducing teacher grading, my TAs graded about 1/5 the work. I've been running my algorithms class with far fewer TAs than my colleagues run their algorithms classes, and this has been helpful. And my TAs are happier with it because even I have fewer TAs, but also those TAs do less grading. Promptness of feedback, as I said, I tend to get the feedback on homeworks back in 3 to 5 days, and before my class, it was taking me a couple weeks. And I think this is a sort of a transformative difference in terms of helping students adjust how they're approaching the course material. I think it enables data mining. I want to just give you some brief stats. So like in my class, if I have 100 students, I usually have them work in pairs, so that I have something like 50 submissions. And I have 18 problems over the course of a term in algorithms. For each submission, I get about 6 peer reviews. That's 2 per student. 3 per student, and so about 6 peer reviews. And then there's a rubric that has multiple elements that students have to fill out. In this version, there were 8 rubric elements. And so the raw data looks like 43,000 numbers that I have over the course of the quarter. So there's a lot of data that's been created in the system. We'll talk a little bit more later about opportunities with such a data set. There are some potential disadvantages of peer grading. I think that you might worry about inaccurate grades if you're not having a TA assess the students. You might worry about students being unhappy with the system. So one of the ways I've addressed sort of inaccurate grades or student unrest is, you always keep a person in the loop, and the person who's most qualified to know if the grades are probably wrong is the student who did the work in the first place. So I give them a appeal option, and my appeal rate is something like 3 to 4%, which is pretty low, which is sort of a metric for quality of accuracy. At least it says the grades aren't too low. Okay, it's not saying the grades aren't too high. Maybe they're too high. And I asked them survey questions about, whether they thought it was beneficial, and only 1 to 6% strongly disagreed with the survey questions about, the benefit of the system. So there wasn't too much protest. As I said, the main challenge that I've been thinking about in this space has been incentivizing accurate peer reviews. I'll talk a little bit more about that. In other words, I'm talking about grading the grading. And the point is that, as I'm sure you guys all know in this audience, if you assign students to do work, you better grade it. Otherwise, many of them aren't going to do it. So that creates both opportunities and challenges. Cool. So I want to talk a little bit about enabling data mining. And I actually am coming to this meeting hoping that uh, that you people in the audience will have a lot better ideas than I've had here. Um, so again, this is sort of what data for one class looks like. I've been doing this for 3 years, teaching a class every quarter, so I have lots of data that's kind of like this. Um, Here are some concerns that I wrote down, not being an expert in educational data mining. So hopefully we can, chat about this and refine these concerns. Um, how should the data be uh, collected, or what data should be collected? Um, could we make changes to the system so that the data we collect is going to be better data? For instance, by instrumenting the system with randomized experiments, or changing how we ask students to fill in reviews and whatnot. What other data in the class should be linked to the peer review data? Should we link in quiz grades and exam grades, other kind of performance? Should we try to link in performance after the class? And maybe this class is a prerequisite for later classes. Should we link in performance to those other classes? What interventions or fine-grained feedback are possible? So far, we give the students, grades like we usually would do in a class, but you could imagine before the midterm, we could say, hey, look, we studied your performance, and we think that this part of, this subject is something you're weak on. You might want to study that more. And of course, with data that's connected to students and education, you have to deal with issues of FERPA and consent and data sharing to make so that hopefully these projects can contribute to the ecosystem in data mining education. So those are the sort of questions that I was thinking about, and probably you have better questions in mind. So my goal is I hope that you can think about what questions you think are interesting, and I'm gonna, in the rest of the talk, describe the system that we have so you'll understand what the data is that we are collecting. Okay, and then hopefully we can have a conversation about where to go from here. Cool, so I'm gonna give a system overview. I'm gonna talk in detail about grading peer reviews because I think that's an important part of the system. And then I'm going to talk a little bit about what I've learned sort of anecdotally about good assignments and rubrics for peer grading. And then I want to, close by, opening the conversation up to more discussion about how you enable data mining in this space of peer grading. Cool. So a system like this has a user interface, it's got some back-end data management, and it's got some peer grading algorithms, which sort of crunch the numbers and decide, outcomes like grades for students on assignments. The main algorithms that go into the system are the matching algorithm, deciding who should grade what. The submission grading algorithm, taking all of the peer reviews and the TA reviews and crunching all those numbers and deciding what grades should be given to the actual submissions that homework submitted. And then there's the review grading algorithm. Again, I've asked students to both do their homework in terms of the submissions, but also provide peer reviews. And so you have to grade the peer reviews. So again, I want to take the peer and TA reviews and somehow crunch those numbers and give back reviews for grades for the peer reviews. Okay, of these three main algorithms, the matching algorithm is fairly straightforward. Assigning something that looks like a uniform random matching, so each peer reviews about 3 submissions, and you can set the number of reviews the TA reviews to something like 10, depending on the size of your class. And that's pretty straightforward. The submission grading algorithm is also pretty straightforward in the literature. Typically, people in this space use EM style algorithms, sort of message passing, trying to basically you want to have your peers on one side and your submissions on the other side, and you want to sort of learn the quality of the submissions at the same time as you learn the quality of the peers, and sort of back out a model, sort of maximizing the likelihood of your model. Okay, so I really want to touch on the review grading algorithm a little bit more because I think it's sort of a sticky point for, one of the new challenges that we're trying to address in the system. As I said before, this whole system is implemented as a Canvas plugin. We're working this summer about making it into a public Canvas plugin that anyone can add to their Canvas and start using. And we're hoping to be able to sort of hot swap algorithms, meaning if you don't like my matching algorithm, you can put your own matching algorithm in there. And I'm hoping that as part of the ecosystem of peer grading, people will experiment and maybe try algorithms that we didn't think about, and then we'll learn a lot as a community about what are good algorithms in this space. Cool. So I want to talk a little bit about grading the grading. So I said we have to grade the grading, and the first thing you might realize is, well, if one of my goals of doing peer grading was making there be less grading for the TAs to do, by having people do more work of peer grading, I have to grade the grading, and now I have even more work for the TAs to do. And so one of the things you might think about doing is sort of automating that. And there's a really impressive and elegant theory called proper scoring rules that is in the sort of incentivized forecasting literature. And one of the main ideas is, suppose an agent has beliefs about whether it's going to rain or not tomorrow. Can I come up with a contract? So the agent will tell me their belief now, and then tomorrow when we see whether it rains or not, we'll give them a reward based on what they said, their forecast, and also what happened. And can we come up with a reward structure that incentivizes them to tell us their true belief? And so you can imagine how you might use this in peer grading. You might say, oh, well, I've had a peer review a submission, and I have a TA review a submission, and let's just compare the peer review to the TA review. We'll view the peer review like a forecast, and we'll view the TA review like the ground truth, like whether it rained or not, and use a proper scoring rule to evaluate them. Okay, so we tried this. It seemed like such an obvious application of proper scoring rules, and it turns out it works horribly. I have a brand new paper with a bunch of Northwestern students on optimizing scoring rules. And what we discovered is that the classic scoring rules in the literature are horrible for incentivizing effort. So we have a new paper that talks about if I want to incentivize a forecaster to put in effort to learn what the weather is going to be like, then I use a whole different set of scoring rules than we would have used that's in the current literature. That, however, is not what we're currently doing in our peer grading system. What we're currently doing is actually having the TAs manually grade the peer reviews, and this is working fantastically. And we found the way to get the TAs to do the grading without that much extra work. So basically, if I have 50 submissions, I'm going to have the TAs grade 10 of them, so 1/5 of them. And every peer is going to be assigned to grade one of these 10 graded by the TA submissions. And then what I have the TA do is essentially fill out this grading matrix. Okay, so here what you see in this matrix, I have a submission up at the top where the TA can look at what the submission looks like. And then the TA gets to see all of the peer reviews. Okay, here's the peer reviews of peer 1, peer 2, and peer 3 on a rubric, which has got 3 parts: evaluating the algorithm, evaluating the correctness, and evaluating the clarity. And you can see numbers here, and the stars mean that the peer has left comments, and if you sort of mouse over that, the comment will pop up as text to read what the peer said. And so then the TA has to assign scores and comments to the submission, and that's sort of the ground truth grade for the submission. And then what the peer does at the same time is they assign scores and comments to the peer reviews. So here you see peer review 1 is assessed by the TA for quantitative, like are the numbers good, is the score good, and qualitative, how are the feedback that the peer left. And so the TA gives those numbers and gives some written feedback. And what we found is that it takes the TA a certain amount of time to come up with grades. It doesn't take the TA that much longer time to actually grade all the peer reviews at the same time. Cool. So this is, and so basically for every assignment, we collect, this kind of data for the submission. So I want to briefly mention what I've learned anecdotally about what makes good assignments in rubrics. for peer review. So uh, good assignments for peer reviews are exactly the ones that you can't auto-grade very easily. So they tend to be open-ended, um, and they tend to be assignments where there's a considerable diversity of answers, so that so like essays on a topic that students choose are great, uh, for example. So there's actually a benefit to the reviewer by seeing multiple solutions. Um, and for rubrics that tend to work well, good rubrics are more general rubrics that look at sort of the basic task that the students are being asked to do in their submissions and not the specific question of the submission. Okay, so for an algorithms class, I might ask them to assess the quality of the algorithm, the quality of the proof of correctness, and the quality of the writing, rather than asking them to specifically evaluate the theorem statement. And maybe it was the assignment was a proof by induction. So did they do the base case correctly? Did they do the inductive hypothesis correctly? Did they do the inductive step correctly? So I wouldn't want to do a specific rubric like this. I want to do a more general rubric. My second example of a good rubric is for essays, but I won't go into the details. Cool. So that sort of wraps up what I wanted to tell you guys about. I think there are a lot of opportunities for doing data mining, especially using the vast amount of data that peer grading is generating. Again, we have data from the peer reviews. We also have data from the evaluation of the peer reviews by the TAs, both the ground truth grade for the submission and also the TA's grades for the reviewers. So cool. So with that, I'd like to wrap up, and I don't know if we have question time now or